Okay, here's a problem for you. We want to find the resolution of a radio telescope, and we'd like to find the resolution using wavelengths of 10 centimeters. That's a typical microwave wavelength for a radio telescope. And here's a typical shot of a typical radio telescope. This one's gigantic, 100 meters in diameter. That is the diameter of the aperture of this telescope from here across to here is something like the size of a football field. So it's gigantic. This is the Green Bank, West Virginia 100-meter telescope. So here's the question. What's the resolving power of a radio telescope like this using 10 centimeter radiation that equals the resolving power of an optical telescope like the one that Galileo invented? And we know that a telescope like that has a resolving power of about 3 arc seconds. So what's the size of a radio telescope that would give you a diffraction limit, a resolving power, the smallest image that you can see with a radio telescope, the sharpest image of 3 arc seconds using 10 centimeter radiation? Now, of course, you have to do two things as you do this. First of all, you've got to know what kind of an equation to use. Which equation describes this? So think about that before you get started on the problem. Second thing is you want to pay attention to units. Units are critical. And as you proceed with the problem and its solution, think about that as well. Go ahead, solve the problem, see if you can work it out, and then take a look at the solution that we'll provide. You can see check and see if your answer was the right one.